Sharma from year 3A, and today I am presenting about lights and shadows. First, what is a shadow? A shadow is a dark image formed when an object blocks light. Things required to form a shadow: a light source, anything that can produce or make light; an opaque object, anything that does not let light pass through; a surface so that the shadow can form on the surface. Properties of a shadow: they are dark and have no color, and may not have details like the real object, and may not be the same size and shape. How do shadows grow and become smaller? The closer the opaque object is to the light, the bigger the shadow will be. The farther it is from the light source, the smaller it will be. Thank you. That's it.
Okay.
Good morning, everyone. My name is Anisha Singh, here to present on how shadows are formed. First, what is a shadow? A shadow is a dark spot when an opaque object blocks light from a light source. In this experiment, I will be showing you on how shadows are formed and how the size of the shadow will affect due to the distance of the light source. As you can see, we have two rulers, a surface, a torch, and a minifig. So, first we will switch on our light source, which is a flashlight. And now tell me what you can see here. A shadow. Now, let's see how a shadow will change size. When you move your shadow closer, it will become bigger. When you put your object farther away from the light source, it will become smaller. But why is this? Because when your object is in front of your light source, when it's closer to your light source, the object will cover more of the light, in result making a bigger shadow. But when it's farther, in result it will become making a smaller shadow. So how do we measure a shadow? So here is a 5 centimeter mark point. So we'll keep it over here. And our shadow is somewhere around 18. So then we'll take, since it's going here to 25, we'll do 18 plus 25, which is 43 right over here. Then we'll keep on doing it but minus 5 centimeters until we go to 25. So when it's at 10 centimeters, it will be at 10, and 10 plus 25 will, and then in result you'll get that number. Thank you, and done.
Good morning. My name is Rishbajul Shah from class 3C, and today I'll present my science fair project. My science fair project is about light and shadows. My aim is to investigate effects of light and shadows. What is light? Light is a form of energy that travels in waves. Light allows us to see the world and objects around us. Light energy comes from various sources like light bulbs, lasers, or even hot objects. What is a shadow? A shadow is a dark area formed when an opaque object blocks light from the light source. Examples: the sun or even a lamp. They appear behind the opaque object as light cannot pass through it. My summary: light is a form of energy that travels in waves. What is a shadow? A shadow is a dark area formed when an opaque object blocks light from the light source. My materials used in my science fair project is a torch as the light source, trees to show the effect of light of the shadow, and a box. In the early morning, we'll see a large shadow. It happens because when the sun's rays falls beside the object, we see the shadow larger. Then in the midday, we see a small shadow. This is due to when the sun's UV rays falls directly over the object, we see the shadow forming around the object. And in the late afternoon, we see a large shadow. because the sun's UV rays falls onto the tree from the side. Then we see a shadow on the side. My observation in my science fair project, the size of the shadow depends on the position of the sun. In the early morning, we see a large shadow. In the midday, we see a small shadow. In the evening, we see a large shadow also. My conclusion, different types of objects determine the amount of light that can pass through them. Different times of the day should give us different sizes of shadows. Thank you.
My name is Rishabh from 3D. Today, I want to present my science project on magnets. I want to tell you about the properties of magnets. Magnets have two poles, the North Pole and the South Pole. The same poles repel each other and push away each other. Different poles attract each other. And the magnet ball moves because the magnet at the bottom of the player and this magnet push each other because the same poles are repelling each other. There's a pull force between the magnet ball and the bottle tops are stuck in the goal because they're made of a magnetic material. Some magnetic materials include iron, nickel, and cobalt. There's a pull force between there's a magnet at the bottom of the players and another magnet that is stuck here. Since magnets are powerful and different poles attract, be careful not to lift up the player or the magnets will attract each other. It is one of the main rules. Thank you. I hope you enjoyed my science project.
Do you think the Earth is a magnet?
Yes.
Why?
Because the Earth's core is made of iron and nickel that are magnetic materials.
What is the use of magnets in your life?
They're used in computers and hard drives to store data. They're used in wind turbines to make electricity. They're used in speakers. They're used in a compass. They're also used in motors.
Longer, the light source is near the object. When the shadow is shorter, the light source is further away from the object. When the object is still, it doesn't allow light to pass through and form the clear and dark shadow. Now I'm going to present about materials. This is an opaque material which doesn't allow any light to pass through. It doesn't allow any light to pass through because it's opaque and you cannot see what's behind it. This is a translucent material which allows light to pass through and hardly forms a shadow. Only the borders are a shadow.
This is a translucent object which allows some light to pass through and doesn't form a clear shadow. Now I'm going to talk about many light sources. When there are two light sources, there are two shadows. When there are two light sources, there are two shadows. On how many shadows there are and one object and many light sources, the amount of light sources, the light sources are, if the light sources are 5, the 5 shadow will form as a shadow. Thank you.
Good morning, everyone. My name is Gianna Rabadia. I'm from 3F. Two amazing parts inside our body that help us breathe. This is called the respiratory system. It brings in the air you need, which is called oxygen, and gets rid of the air you don't need, which is called carbon dioxide. We breathe in and inhale through our lung. We inhale air. Air passes through a tube called trachea or windpipe and branches into the two lungs. Inside your lungs, oxygen mixes with your blood. When we breathe out, we exhale air. Exhale means when we breathe out. Our trachea splits into two tubes called bronchi. Bronchi splits into smaller tubes called bronchioles. Did you know while we're sleeping our lungs are still working? If we didn't have them, we could not be able to run, talk, play, or even think properly. Now I'm going to show you how our lungs work. Now this is an open lung when you cut open a lung, and this is a closed lung. I'm done. Thank you.
Good morning, everyone. My name is Gianna. Today I'm going to present about forces. A force is a push or a pull. A push moves an object away from you and a pull moves an object towards you. Without forces, nothing will ever move. My first model is a swing. The swing is made out of cardboard, sponge, sticks, string, cupcake mold, toy and some flower decorations. If you want to make the swing move, you should apply a push force so that the swing can go high up. The swing will come back down because of the gravity. A gravity is pulling things to the center of the earth. My second model is a whale. The whale is made out of cardboard, sellotape roll, sticks, pulley, string and some flower decorations. The whale has a string and a pulley that is a wheel. The pulley helps so that it can be easier to pull the string. Let me show you how it works. When you pull the string, the bucket comes up. Miss, would you like to try how it works when you pull the string?
She can try.
A pulley helps so that you don't need to be super strong. A pulley is a tiny helper wheel that can make lifting things easier. My third model is a wheelbarrow. The wheelbarrow is made out of cardboard, manila paper, styrofoam, sticks, contact glue and hot glue. There is a building that is being constructed, and the building that is being constructed is made out of styrofoam. The wheelbarrow carries bricks, and the wheelbarrow has one wheel at the front and two handles at the back. The harder you push, the faster it moves. If you stop moving, the wheelbarrow will stop moving. My fourth model is a suitcase. The suitcase is made out of manila paper, sellotape,
multicolor sellotape, zip, straw, sticks, and some cardboard, and a cable tie. Imagine you're landing at Jomo Kenyatta International Airport with your suitcase with wheels. Here are the wheels. Let me show you how it works. When you pull your suitcase, you are using a pull force to pull your luggage, and the wheels help so that it can be easier to pull your luggage. That was all about push and pull forces. I hope everybody understood about push and pull forces. Any questions, please?
Who is pulling you on this?
Did you know we live on a giant rocky ball which has layers just like an onion? Today I'm going to tell you about the 4 different types of layers. The outermost layer is the crust. It is the thinnest layer, just like an apple skin. We have 2 types of crusts, the oceanic one and the continental one. The oceanic one is found on the ocean and is 3 times thinner than the continental one. The continental one is found on land, which is where we live. The second layer is the mantle. It is also the biggest layer. It is made up of thick, hot, squishy rocks, just like Play-Doh. The mantle has plates which move. This causes earthquakes and volcanoes. The third layer is the outer core. It is made up of melted iron and nickel. This creates a magnetic field which protects us from the sun's rays. Did you know it is hot as the sun's surface? The last layer is the inner core. It is a solid ball made up of iron and nickel. Why is it a solid ball? Because of the extreme pressure there. It is also the hottest layer, hotter than the sun. How did we find about the layers of the earth? The scientists used the earthquake's waves to study about the layers.
My name is Gian. Today I'm gonna explain about germination. I'm gonna show you the process. First, get a pot. Then choose any seed you want and put some soil and then put the seed. Then water it and put it in a sunny place. Then if you repeat that process for a few more days, a root will appear. Then same thing, except putting more soil and putting a seed, then the leaves will appear. Then same process, then you'll get the shoot, and then you will have your plant. Thank you.
Good morning, my name is Mark. My science project is based on growing plants. Did you wonder there are plants all around us? Let's find out how they grow. First, I'll show you how to plant a seed. First, you have to get a pot, put some soil in the pot, make a hole, drop a seed into the hole, fill the hole with soil, get the seed some water, put the label on your plant, put the pot somewhere light or warm. Now I want to tell you how the stages of germination grow. A seed turns into a seedling or a young plant. A seed, and then the root grows, and then the shoot appears, then the leaves appear. Now I want to tell you the conditions of germination. You need light for the plants to see. You need light for the plants to see, stay warm, and air and oxygen and water for them to be healthy. I hope you understood. Thank you.
Good morning, everyone. My name is Tiara Gosrani. I'm going to present facts affecting germination. So, these are the stages of germination. First, a seed, root grows, shoot appears, leaf appear, then the whole plant. Germination is a growth of a seed or a young plant into a seedling. First, I took a container, then I took cotton, then I put seed. The next one, I took a bottle, I put cotton, then I put water, then I put a sponge, then the next one is, first I took a bottle, then I put cotton, then I put water. So first I put a seed, then I put cotton, then I put water, then it was ready. The next plant, it fully grown. I took a big container, then I put cotton, I put a seed, I watered it, I kept it in sunlight to make it grow. So the stages, so the leaves are bent because they need sunlight. Without sunlight, they will not grow. If I put the plant in a dark place or I don't water it, it will die. Thank you.
Why do you think leaves are needed for a plant? What does a leaf do in a plant? What do the leaves do for plant?
It makes food for the plant.
On the roots?
the plant family in the soil.
Yeah, what else does the roots? What else do the roots do? Apart from holding, what else do the roots do?
Inside there are things growing.
And in this, do you need sunlight here?
Good morning, my name is Pankti and today my topic is about us and our senses. First off is sense of sight. We can see with our eyes. We have some parts of the eyes. They are called pupil, iris, optic nerve, cornea, and retina lenses. Cornea allows us to focus on objects. And sense of sight. I can see with my eyes. We can see sun, clouds, moon, stars, and TV. Sense of smell. We can smell bad smell or good smell. Good smells like perfume and other smells. And we can smell bad things like burnt food and others. Noses helps us to breathe, storing help us to we can smell the flower, perfume, air freshener, incense sticks. Sense of hearing. If we hear more than 100 decibel, our ears will get damaged. And if more than 140 decibel, we'll be deaf. We can hear bird, drum, phone ringing, loudspeaker, and sound. Sense of taste. We can taste with our tongue. Tiny dots on our tongue are called taste buds. We can taste sweet, salty, sour, bitter, and ice cream. Sense of touch. We can touch with our hands. We can touch hard surface, soft things, rough surface, and smooth texture. Thank you.
Can you hear me?
Yes.
If I go there, will you be able to hear me?
No.
Why?
Because if you are far away, you cannot hear. But if it's near you, you can hear it.
Good morning, everyone. My name is Mikal from class 2A, and I'm going to present make electricity. Can you imagine you're at home, but the electricity is gone? Did you know you can make your own electricity? I can show you how. But before I show you how, there's a few things you'll need from home. Salt and vinegar to make the electrolyte, a multimeter to show how much electricity is being produced, an aluminum foil because it's a good conductor of electricity, paper, copper coins and silver coins, a spoon, a cup. Put the vinegar inside your cup Then put a teaspoon of salt. Mix it until it dissolves. Take your piece of aluminum foil, place it on the piece of paper, place your silver coin, take a piece of paper, dip it in your electrolyte, place it on the silver coin, add a copper coin on top, then take your multimeter, place the red on the aluminum foil and the black on the coins. The numbers you see on the multimeter tells how much electricity is being produced. Do the same process again. Did you realize how much electricity is being produced? And again. Did you realize that the more coins you put, the more electricity is being produced? Thank you.
Good morning, everyone. My name is Ditya Khurana from 2B. Today, I am going to present my scientific investigation on forces and movements. So, let me tell you what a force is. A force is a push or a pull. Forces can make things move, stop, or change direction. A force we may all know is gravity. Gravity is a force that pulls everything down to the ground. That's why things fall when you drop them. My science investigation is on a force known as friction. So what is friction? Friction is a force that slows things down when they rub against each other. For example, when I rub my hands together, they get warm. That's friction. And when shoes help us walk without slipping. Brakes on a bike use friction to stop the wheels, thanks to friction. Now, I am going to do a toy car experiment. On toy car experiment, we will need a ram, a measuring tape for accuracy, two surfaces, smooth and rough. Our rough surface is called the forest road and our smooth surface is called the highway. I'm going to put the zero mark to the corner and see how many centimeters it went away from the ramp. The car went 18 centimeters away from the ramp. Now we will try on the rough surface. went 9 centimeters away from the ramp. To make the experiment fair, I used the same height of the ramp, same car, same measuring tape, and the difference is they are not the same. The rough surface is not the same as the smooth surface. So the conclusion is some surfaces slow the car down because of something called friction. It's a rubbing force. Smooth surfaces have less friction, so the car goes farther. Rough surfaces have more friction, so the car stops sooner. Thank you. Today I'm going to present about forces and movement, and I'm going to do 4 experiments. And my first experiment is about friction. I have 2 books and I'm going to connect them together and you tell me if it's going to fall or not. Is it going to fall? Yes, because I put only a little pages together, that's why it fell. Now I'm going to do another way and you let me know if it's going to fall or not. Is it going to fall? No, because I connected many pages together, and that's called a force called friction. Now I'm going to do my second experiment, and it's about push and pull. So I have a bean and I'm going to put it here. I'm going to apply a little force to the spoon. It went very near because I applied a little force to the spoon. Now I'm going to apply a more force to the spoon. It went very far because I put more force on the spoon. And now I'm going to do my third experiment, and it's about motion and movement. I have a rough road over here and the car won't move because it's a rough road and the car will get stuck. But if I put a little force, it will go down. Now I'm going to do the smooth surface. It went very smoothly because it's not a rough surface. Now I'm going to do my last experiment, and it's about magnetism. I have a ghost over here and I have a magnet. I'm going to put the magnet next to the ghost and it will come up because magnet and metal attracts together. Thank you.
Have you ever looked at a pencil in a glass of water and noticed it looks bent or arrows behind a glass of water? Today I'm going to show you how light bends and why the pencil is looking bent. Hello everyone, my name is Priva Gandhi from 2D. Today I'm going to demonstrate bending reality through refraction and optical illusions. Refraction is the bending of light from one medium to another, like air into water. Examples of refraction: a pencil that seems to be bent in a glass of water, or a coin that seems to disappear under a glass of water. Refraction happens because of changes in speed of light and changes in direction. Now we move on to the most amazing part of the topic, optical illusions. Optical illusions trick our brain into seeing something different from reality. Optical illusions and the concept of refraction all help us to understand how our eyes and brain work together. Please take some of these forms. Here is a display of my project. Over here, the pencil is bent in half. Over here, there's a coin under, but you can't see it. Over here, the arrows are not changing sides because the glass has to be round in shape so that the light can bend. Did you know that a magnifying glass is also refracting? Now I'll do the experiments. See, here is a coin. If you see the coin, it means that you're looking at the wrong direction. But if you don't see the coin, it means you're looking at the correct diagonal. Do you see the coin? If you look on top, the coin is inside. Or if you look under, you see the coin. But if you look from the side or front, you can't see the coin.
Let me see.
See, there's a coin.
Oh yeah.
This one, the pencil will be, is not bent, but when you put it in the water, it will bend. See? It's bent, even though the pencil is not bent, because light is bending. It will start to spin. Now let's do the last one. The arrows are facing this side and now they'll change. Wait. I have to go a bit far. It's changing. Over here, the arrows are not changing because the glass has to be round so the light can bend.
Good morning. My name is Dariela Liama Okwayo from class 2E. Today I'm going to present to you electrolyte sensor. Electrolyte. What is electrolyte? When athletes sweat, they lose electrolyte in their bodies. Electrolyte is an electrocharge that helps our body function. So today we're going to be testing the drinks that replace the energy drinks that normally replace electrolyte that's lost in an athlete's body. We're going to be using water, salt and sugar solution, lemon water, Reload, Monster, and Red Bull. First, we have to make sure the voltmeter is on. The voltmeter is going to help us check the reading and write it down.
Turn this side. So camera can capture the light. Good.
Next, you take the two clippers on the foil. You take the sensor, pour the drink, and put the sensor inside. Check the remove the sensor, check the reading, and write it and record it. Next, you remove the clippers, put it on the next solution. The next solution is salt and sugar solution. You take the sensor, put it in the drink, remove the sensor, and write down and record the reading. Next, we put the clippers on the foil. Next is lemon water. You take the lemon water, pour it inside. Take the sensor, put it inside the lemon water. Check the reading and write it down and record it. Next is reload, an energy drink. You take the sensor, put it inside, take the drink, pour it in, and check the reading and write it down.
Can you put this so that we can see it?
And record the reading. Next, you remove the clippers, put it on the next drink. The next drink we're having is Monster. wire it in. Take the sensor. Put it inside the energy drink and write down the 0.10. The one with the most electrolyte was salt and sugar solution, meaning it will restore a lot of electrolyte that was lost inside the athlete's body. Thank you.
Why did you choose this project? It is interesting, but I need to know.
Because I was interested in athletes and circuits at the same time.
Circuits at the same time.
Yeah.
Hey everyone, can you imagine a world with no electricity, which means no lights, no TVs, no fans, and no fridges, and worst of all, no phone charging? It would be like going back to the Stone Age. Scary, right? Thank goodness for Benjamin Franklin, who was a clever person and found out that lightning is actually electricity. Welcome everyone. My name is Kiara Shah, and today I am going to take you on a fun journey to learn all about electricity, what it is, where it comes from, and why does it sometimes just disappear when it rains. Let's begin. What is electricity? Electricity is an energy that makes things work in homes, schools, and factories. We can't see electricity, but we can see what it does. For example, it turns on lights and makes the TV work, it runs the fan, and most important, it charges our phones and tablets. Now that you know what electricity is, do you know where it comes from? Does it live in the walls? Does it grow in the plants or trees? Nope, I checked. Electricity is made in big places called the power station, like this. They use different kinds of things like solar energy, bioenergy, hydropower, wind power, and geothermal power. Once it is made in the power station, it goes through wires to the transformer, then to the electric poles, then reaches our houses, schools, and factories. So the next time you switch on a light, that light has traveled a long way to reach you. Electricity needs a path to travel, just like train needs tracks to travel. This path is called a circuit. Remember that electricity can't pass through everything, only a few things. Let me show you. This is a circuit. It has a switch, bulb, and battery and wires. Do you think the bulb will light up? Let's test. No. Why? Because the wires are not connected and it's an incomplete circuit. But when I connect the wires and I test, it will light up. Why? Because it's a complete circuit. Here I have some materials and I am going to test which one lets electricity pass and not. First, let's test wood. Look, the bulb is lit up because wood cannot let electricity pass and it's a non-conductor. Look, I have rubber. This means it's a non-conductor. Let's test metal. Look, it's a conductor of electricity. Do you think it will pass through plastic? Look, it's a non-conductor. Now let's try a pencil lid. It's supposed to work, but no.
Have you connected properly?
Yeah.
Maybe it is broken inside. Those pencils generally, when it is broken inside, it happens. It's okay. You know that it's supposed to work, yeah?
As we just saw that plastic is a non-conductor of electricity. That's why the wires are covered with plastic to keep us safe. But if it wasn't, we would get a shock.
How do you use these conductors and insulators in your daily life? Where do you see them?
Conductors we see in
Like in your house or in the classroom or wherever. Where do you see them?
when the bulb will lit up through that material.
In this wire, right?
This one.
Wire you have used, right?
Yeah.
So, what is a conductor here? What is a non-conductor in the wire? Only in the wire.
The metal.
What is a conductor?
The metal.
The metal. And what is a non-conductor in the wire?
The plastic.
Where is the plastic?
Outside.
So, do you see this again somewhere else also? Where? Where do you see this conductor and insulator?
The ICT lab.
ICT lab. You see the wires, right?
Yeah.
Apart from wires, any other way we are using them?
It has been raining the past few days, and have you noticed there's been a power cut? Why? There are 3 reasons. First reason, wind breaks the circuit. When it rains, it becomes very windy and stormy. That makes the electric poles and trees to fall. This causes a broken wire. Broken wires is an incomplete circuit, and incomplete circuit we have no electricity. Reason 2, dirty water causes a short circuit. Did you know that clean water isn't a very good conductor of electricity and dirty water is? Don't believe me? Let me show you. Here is clean water and here is dirty water. Look, the bulb lit up but not very bright. This shows that it's a non-conductor of electricity. Now let's try dirty water. Look, the bulb lit up very bright. This shows that it's a very, very good conductor of electricity. When it rains, the rainwater mixes with the dust in the air and that makes dirty water. As we just saw that dirty water is a very, very good conductor of electricity. Electricity takes a shortcut through the rain and this causes a short circuit. A short circuit is very dangerous. That's why the power station switches off the electricity to keep us safe from a short circuit. Reason 2. Lightning is super hot. Did you know that lightning is even hotter than the sun's surface? If lightning touches the wire will burn and break. This causes an incomplete circuit. Incomplete circuit, no electricity. But wait, in some of our houses we still have electricity. How? Is it magic? No, it's an inverter. Inverter is a battery that stores electricity for us to use later, just how you save some snacks to eat later, just in case you're hungry later on. This has come to the end of my project, and to end my project, thank you all for joining me on this fun adventure to learn all about electricity. So the next time it rains and there's a power cut, you will know why and you will remember me. The end.